Hello and welcome back. I'm Matthew, and this video is part 4 in our series on installing MVS 3.8 using Jay Mosley's SISGen instructions. So this is a fun one, not that the other ones up to this point haven't been, but this is really where we are building our OSVS2 MVS control program. This is the kernel and what's called the nucleus in IBM mainframe terms, as well as the various supporting programs and everything that goes into making the system bootable. So without further ado, the prerequisites we should have all in place if we've been following the instructions and the videos up to this point. So we can skip through all of those. You'll see our first step is to create additional DazD volumes. Like previous steps, we need some extra hard drives in our emulated system. These will be the volumes that we are generating the system onto. So our system residence volume, an additional system data volume, and then a spool and paging volume. So we use the create DazD script for that. So create DazD SISGen. So back over in our console, we'll run that create DazD with the SISGen parameter. And we can see that created our MVS res, our MVS 000, spool 1, and page 00. Okay. So if we take a look at all of our DazD now in the DazD directory, you'll see those new volumes along with the volumes that we've created from previous steps. The instructions remind us about that check condition code script. We'll continue to use that. And here's the system we're using now, similar to the previous step, but we will add those additional DazD volumes. And we continue to have our 3215 console, which is just a line-oriented printer and typewriter keyboard input. We're not onto the full screen 3270 terminals yet. We'll have our card punch, which will become important in later steps this time around. And we have our printer and our reader and a tape drive, just in case. All right, so we start Hercules up with the configuration file for this hardware configuration, SISGen.cnf. Let's go ahead and do that, and then we'll connect our console, and we can IPL our system. So back over in the console in our Hercules window, we'll run Hercules conf SISGen.cnf. Again, once Hercules starts up, I can hit escape, just kind of verify that the device list is what we expect. You'll note those new volumes are not added here yet. That's because, like in the previous step, we don't want them attached to the system when our starter system that we're still working with initially IPLs, because it could try and use them for something else, and the volumes aren't initialized yet, so I guess it could cause confusion. So we're going to see that after we bring the system up, we'll attach the volumes to the system, initialize them, and then they'll be ready for use. Hit escape again to get back to Hercules. Remember, before we IPL, we need to make sure we have our console attached. So telnet localhost 3270 to connect to Hercules. Okay, we're connected. And then back in Hercules, we IPL from device 150. Okay, so that's getting up and running. We go back to our console, and we are being prompted by MVS to specify system parameters for release 3.7. Let's go back to the instructions. It looks like in this step, we do want to do the CLPA option to rebuild the link pack area. So we'll reply with CLPA. And then on the JES2 startup, we can just do a JES2 warm start. We don't need to format the spool area in this case. Okay, so CLPA, and then a regular startup of JES2. So here we reply 0, CLPA. Okay, JES2 startup, we reply 0, no REQ. All right, looks like our system is started up. So back to the instructions. As we did once before, we want to ensure that there's just one job executing at a time. So we're going to stop initiators 2 and 3. So let's go ahead and do that now. Okay, looks good. And now back in Hercules, we're going to attach those additional DazD volumes we created. And there's a script in here that has the commands to do that. There's attached commands, and then the syntax looks like what you'd see in the Hercules configuration file. So we can run that script over in the Hercules command prompt. And there we go. We can see all 4 of those devices attached successfully. So now that they're attached, we need to initialize them, and we have some preparation steps for system generation. And that will be the SISGen4 script. So as we've been doing in the previous videos, we just paste these dev init commands into Hercules to load these JCL job streams into the card reader. So we'll go ahead and run this job. And if we look at our MVS console, we can see there's prompting for a reply. As before, because this is running a device initialization command, we're being prompted on the console, hey, do you really want to do that? We're about to alter this volume. So we will reply U to these messages. So R1, because this is message 1, U. Same thing for volume 14A, reply to U. Reply 3U for volume 14B, and reply 4U for volume 14C. And that should be all 4 of those new volumes that we created for this step. Okay, so now it's asking us, do you want to run these operator commands in your job stream? In this case, we're trying to vary those new volumes online. So yes, that seems like a safe thing to do. So reply 5 with yes. And now we are going to mount each of those volumes. Again, there's operator commands in that job stream, and the system is configured to prompt the operator if they really want to run those commands. So yep, we want to mount, it looks like device 149 with the label MVS res, and volume 14A with label MVS 000. So reply 7 yes, and so on and so forth. Reply 8 yes, and reply 9 yes. Okay. There we go. All available functions complete. So that job finished up. We can go over to our, let's see, hit the wrong button here. Go over to our, sorry, back to the console. Go over to our Linux shell. There we go, 3rd time's the charm. And again, we can use that cond code script on the printer output file and check job SISGen4 that we just ran. You can see we have one step, the first step, with a completion code of 8, and the rest of them have a completion code of 0. So we'll just go back and check the instructions to make sure that 8 is expected here. I suspect it is because this is probably trying to do some cleanup of files that don't exist, so they don't need to be cleaned up. We can confirm that in the instructions where they hopefully have expected completion codes. Sure enough, these are the completion codes we got, so everything worked well. All right, SISGen1. So let's look at this JCL, SISGen1. We'll go back over to our shell here, and I'll open up JCL SISGen1. So this is a critically important step. It's also really our first opportunity to make some pretty major modifications to our system and deviate from the instructions if we wish. We're only going to make a couple of minor changes here, but it's worth understanding what's going on here. So this is the stage 1 assembly of system generation. We're essentially passing a bunch of macros, assembler macros, to the assembler to generate what will be our stage 2 system generation input. Now, what are all these assembler macros? Well, this is how we define our system. So you can see, for example, there's a macro here for the master console, and it's going to be at address 010. So when I then make my Hercules configuration to run the system that I've generated, I need to make sure that my master console is at address 010 because that's where I've defined it in the system that I'm generating. We have an alternate console at address 009. And as we go down here, we can see that we have the actual I/O device for that defined at 010 as a unit type 3277, so on and so forth. Also, all of the devices that can be attached to the system need to be defined here. So where can I put my card readers and punches? Well, in this system, I'm saying there's a reader at address 00C, and there's a punch at address 00D. We can define where our printers are. We have a 1403 at 00E. We have another reader. We have another punch, another reader, another punch. Essentially, any hardware you might want to attach to the system, you need to tell the system during SISGen where those hardware devices are in terms of their address, the type, features they have. Our tape devices, so we'll have 4 tape devices of type 2401, model 6, starting at address 100. So address 100, 101, 102, and 103 are valid locations I'll be able to attach a 2401 tape device to my system. Same with the 3420 device at addresses 110, 111, 112, 113. If we keep going down, here are DazD, model 3330, 3340, 3350. I can attach 3330 DazD devices to the addresses starting at 138, and we create 8 of those. 140, and we create 8 of those for 3340s. Okay, does that make sense? All the way up to our 3390s, right? So if I want to add additional 3390 disks to my system in the future, I can't just attach them to any arbitrary address. I need to make sure I'm using an address that was defined in the SISGen for that device type. In this case, I can add 3390 devices at addresses 190 through 197 because I've created 8 of them starting at 190. Now, if I need to add more than that, if I've run out of potential slots, that's when I need to do another SISGen, or what's called an IOGen, which is kind of an abbreviated SISGen that will rebuild the nucleus with updated device address tables. So, of course, the Hercules configuration that is provided for us for running our system will have all the devices at correct addresses. But again, if you're going to add more down the road, and I often add more DazD just to segregate the data differently, or if I need more space, you just need to be aware of, well, how do I know where I can attach them? And the numbering scheme is defined in this file. So those were all the channel 1 devices where the address starts with 1 in that position. Channel 2 devices, we have more, so you'll see there's more slots to attach all the different DazD types. And we can just keep going through here. Channel 3, channel 4, channel 5. All right, so we don't need to change any of that. This is really generated with probably more hardware than we will need for our emulated system. So that's all good. But the other interesting pieces of this configuration, symbolic device names. So if you're using, I think they're also called esoteric device names, where you'll say, the device, I want unit SysDA. So you're not naming a particular type of device or address. You're just saying, hey, any SysDA, this is a common name to use for direct access storage on the system. And you'll see over these few SysDA lines, it includes all of those addresses where we said we could attach DazD devices, direct access storage devices. And so when you're using a name in your DD statements in your JCL on your system, and you say SysDA, this is where that SysDA name is defined. It's not just some magic name that the system infers or pulls out of thin air. It was defined here during system generation. So control program options. So here's another macro. control program, and we have several options that control the system we're generating. Now, I'm going to switch back over to the web browser. And all of this is documented in the system generation reference. And luckily, this is another document that is archived on our favorite site, BitSavers. And looking through this, let me go down to the table of contents. Somewhere down here in a couple of pages. Here we go. So this is the documentation on generating an MVS 3.8 system. You can see that we have documentation for those control program options that we're looking at now. The couple things we're going to change, I learned about and how you can change them by looking through, well, what can I put in that control program macro? You can see our unit name. These were those generic device names. You can see our I/O devices. Those were where we were saying, okay, here's the kind of device at a particular address. That console macro. So it's all documented in here, and you can learn what each of those options does. If you look further in here, you can see preparing for system generation, initializing the direct access volumes, starter system, getting the distribution library tapes, initializing the volumes that will contain the starter system. So these are the steps that look an awful lot like what we've been doing in the previous videos, in the previous steps of Jay Mosley's instructions to prepare us for this point of now performing the system generation. So if you really want to understand more in depth this whole process we've been going through, starting with those starter system tapes that we restored and booted from and have been running our system on so far, it's all documented in this the system generation reference guide. So good stuff. So let's look at, let's see, we are in the control program macro. So let's look back in the documentation, and it's on page 48 of this PDF, the documentation for this control program macro. And here it gives us the little syntax overview. We can say control program, and we can optionally include all of these parameters, which then further take their individual options. And the first one that I notice is this ACR code, alternate CPU recovery and interprocessor communication routines. It defaults to yes, but if we look at the JCL, I'll flip to it in a second, it's been specified to no here. And this limits the system to a single CPU, a uniprocessor system. Well, I might want to run 2 processors on the system that I generate. So I'm going to change this from no back to the default of yes. And we can do that by modifying the JCL here. You see we have ACR code equals no. So let me change that word to yes. Now it's really important to understand that this file is an assembler file. It's being run through the basic assembler, and these are all assembler macros that will then produce a lot more assembler code that gets compiled into our generated system. So the assembler syntax is very picky. It is for 80 character wide card images. I have this red bar in Vim indicating column 80 here, so you can see these all end exactly on column 80. But really importantly, this continuation character has to be in column 72. So since I changed the word no to yes, it ended up spacing that over one more. That would now be a syntax error. So I needed to delete that extra space and get this back in. Because again, this control program, this is one assembler macro. The commas continue it here along with the continuation character here. And it ends after this TZ parameter. We don't have the continuation character. That's the end of this control prog macro. Okay. Some other changes. It looks like we have the first opportunity to set the time zone here. I am neither 1 hour nor 5 hours west of GMT. I am 8 hours west of GMT when we're on normal time, winter time. And I may as well update the comment here just because comments out of sync with the code kind of bother me. And again, I'm going to bring this back in so that we keep everything aligned properly and in the correct position. The last change I'm going to make is this RDE. So control prog options, and then you can see options is this list inside of the parentheses. Let's go back to the documentation. And options, so we're inside the options section. You can see various options we can list here. RDE is the reliability data extractor feature. This is something that helps you if your mainframe is, say, crashes unexpectedly or you're having to reboot unexpectedly. It'll log various hardware errors it detects. In the real world with real hardware, this is probably pretty important because you're going to take this data, you're going to work with IBM on understanding why things may not be working the way they're supposed to. But in the emulated mainframe world, I'm not all that interested in this, particularly because it always prompts whenever I IPL the system asking, oh, what was the reason that you just re-IPL'd the system? And that's not data that I need to track. So if we remove RDE from the options, we won't include this reliability data extractor into our nucleus and our system control program. And so it's just one less thing to worry about that isn't really applicable, in my mind at least, to my personal emulated system. So let's go back and we will just remove that line entirely. And now we're left with the options RER, DevStat, and BLDL. Again, you can go read what those mean if you're interested. Okay, so we have enabled ARC code, so we can have a multiprocessor system. We've set our time zone. We removed the reliability thing. And the rest we're going to leave as is. We make sure that all these continue characters ended up in column 72 again. They did. So that looks good. You can see there's some other options here relating to the job scheduler, some TSO options, optional access methods, making sure this is where we get VTAM enabled for our system. We have 3270 support. So again, important options to have in here. You can read more about them, but the SISGen job stream here has reasonable defaults. Okay, here's where we're defining the data sets for our system. So really, this is the starting point of, well, where is everything on my system? You know, why is there a data set on sys1 called parmlib? And where is it? Well, on this system, we're generating a system where it will look for our parmlib named parmlib on MVS res, that's the volume label, which is a 3350 device. And it can take up this much space. So these user services, this is an area that actually I don't fully understand. I think these are basically, you can almost think of them as add-on system calls, I think. They're able to plug into. We can see authorization. This is eventually where the security system will end up if we add on the security product. So I just leave those as is because I don't quite know why or how I would change them. And then this is the final command to actually generate the instructions we need for the system generation. Okay, I'm going to save that modified SISGen01 file. We'll return to the instructions. And it's now time to run that stage 1 SISGen. So let's go back to the Hercules console. Paste that in. Run that. Okay, so that's running. We'll give it a minute here. And what this will do is punch to our card punch all of the JCL for the stage 2 SISGen, which is where the actual work is done. Essentially what we've done is we just expanded all of those macros into more code that we can then run, which will do the work and build the system the way we specified in those macros. So all available functions complete. That means it's done. Let's look at the condition codes back in our shell. So that was from SISGen01. Okay, so we have a cleanup task that has 8. That's probably expected because we haven't done this before, so there's nothing to clean up. And then it looks like we got good codes from the assembler and punch steps. Back to the instructions, we can see, yep, 8 was expected, and then all zeros. Okay, so this created a bunch of output on the punch output. So let's look at that punch output file. You can see that's a file that Hercules creates for us for our virtual card punch. And let's look at pch013.txt. So it made this output. You can see it generated some JCL for us here. It looks like it has some separator cards that it created between some of these. So we know we probably can't feed those back in. Those aren't valid JCL. But otherwise, it's generated a bunch of what looks like probably more assembly code and more macros. And this is what will actually be assembled and built into our system control program. So looking back at the instructions, here, they're walking through some of the changes we need to make to that punched output to turn it back into valid JCL that we can run, as well as some options, for example, to hold each job so we can just load all of that into the system and then run the various steps one by one, adding some time parameters, increasing the expected output, making sure that our system catalog for our generated system is included, and using, looks like we just changed this to a dummy program instead of a access method program. So again, several things we need to do to take those punched card images and turn them into something we can turn around and feed back into the system to actually run those jobs. You can do that manually. You can learn a little bit about JCL by doing this, and it kind of starts making sense. Okay, yeah, this is why we need to do those steps. But for convenience, Jay also provides an awk script for us that will make those changes for us. So I can use that stage 2 awk script to read the punch output and create a stage 2 JCL file that has all of these changes applied to the punched output, and then I get my nice clean JCL for that. So let's go ahead and do that. And let's go back over to our shell here. I don't know if this is installed as gawk or just plain awk. Yeah, command not found. So we only need the awk portion of it. It's already GNU awk on Debian. Okay, and that's done. Now, if we look at that stage 2 JCL file we just created, you can see, for example, that initial card separator line is gone. We have the hold directive added. We have this time directive added. So all of those changes have been made to all of our jobs. See, there's job 0, there's job 1, SISGen3, SISGen4, SISGen5. So there's several jobs in this deck of cards now. So now that we've created those, we will run, or we'll put that big stage 2 JCL deck into our virtual card reader. So we can do that over in the Hercules window. Okay, it reads that all in. If we look back at our operators console, you can see that we read each of those jobs, SISGen 1 through 5 on our reader, but they're all held. So they're in the system, but they're not running. Whereas all the jobs up to this point, we've dropped in the card reader and they've immediately started running. But because we added that hold line to each of the jobs when we modified the SISGen JCL, they're now just sitting in the system waiting for us to release them. And we'll do that, and we'll just release them one at a time to make sure that each one finishes before we move on to the next. So let's look at the instructions. It'll tell us how to do that. We use the $A command. So this is a JES2 command to release a job. And we have the jobs SISGen 1 through 5 held for us in the system. So we can just run those one at a time. Let's run the first one. None of these take particularly long. Some are quicker than others. So we'll just patiently wait for them to complete. There we go. So SISGen 1, all available functions complete. Before we move on to the next one, let's check the condition codes from that job. So SISGen, this was SISGen1 this time instead of 0, 1, which was our earlier job. All right, so that's a lot of output, but it looks like it's all 0s and 4s, which are usually okay. If we look at the instruction, yep, it looks like we are expecting some 4s. We should end up with SG40 as the last step. So we can always, it's good just to double check that we didn't somehow bail out early. So if we look at our output, yep, SG40, we got 0s. That looks good. Now we move on to releasing the SISGen2 job. So the same thing on my operators console, I will $A quote SISGen2 end quote. So now the SISGen2 job is running. While we're waiting for that to run, let's just preview. We're expecting, again, a couple of 4s, mostly 0s, and we should end up with the last step of SG45. Okay, that's complete. Switch over to the shell, check SISGen2, mostly 0s, a couple of 4s, and we got all the way through SG45. So that looks like it worked. We now go back to our operators console and release job SISGen3. Okay, that one ran quickly. Let's look at the condition codes for that. So 3 steps, all 0s. Check our instructions here, and that's the expected result. Let's release job SISGen4 back over on our operators console. $A quote SISGen4. Wait for that to run. Let's go ahead and look back at the instructions. So we should expect 0s with 1 4 up through step SG8. All available functions complete. So we'll check SISGen4. Okay, it looks like it's sorted differently in the Perl program than the Rex script. So we didn't actually finish on SG8, but we got all 0s. Let's look over. Oh, I just read that wrong. It is 18. So nuke 14, it looks like we actually got a success instead of a warning. Let's look back and just confirm that everything looks okay. Yeah, so we did get that 0 instead of the 4. Given that we got a better completion code, meaning a less severe warning, in fact, a complete success, no warning at all, I'm going to assume that this is okay. This could be because I enabled multiprocessor support. Maybe it gives us a warning if we have uniprocessor support. It could be because I removed the error reporting, logging stuff, and maybe having that included generates a warning of some sort. So in this case, I'm not worried about the fact that I got different completion codes because I got lower numbers. Lower numbers are better. If I had gotten an 8 here or a 12 here, that would be an indication to me that something went wrong. All right, back to our operators console. Last but not least, let's do $A SISGen5. Okay, we get this funny message. The instructions will tell us that that is expected. Oh, I said last but not least, but there's actually a SISGen6 in there as well. So we should get all 0s on the SISGen5 step. All available functions complete for SISGen5. So let's look at the results of that. All 0s, perfect. And now, for real this time, last but not least, $A SISGen6. Okay, all available functions complete. Check the completion codes. Oops, that was not the key I wanted to hit. Control A2. SISGen6. Looks like, so we have 0s, and step Z1 we have an 8. So we'll confirm that that's expected. Yep, so that's fine. And here's an explanation of why we have that. Here's that note that that log message or that console message is expected. And so that is our SISGen. All right, So before we can actually boot the system, we also need our job scheduler. So we're using DazD. So this next SISGen2 JCL, we're now back to the JCL that is included in that package we downloaded from Jay Mosley. This is no longer our generated jobs that we've been running. We need to set up some files to link DazD and then also create our DazD parmlib member, basically the configuration file for DazD, as well as the proclib member to start it up. So before we do that, there is a small modification I like to make to my DazD system. We can do this after the fact, right? This will end up as a file in our sys1 parmlib, so we can always change it later. But I like to just do it now. So we're going to edit the SISGen2 JCL. So vim JCL SISGen2. You can see here it's linking. That's actually building the DazD module. And then we're using, let's see, where's our job statement here? Here we go. So then we're using IEB update to create this DazD PM00 member in our parmlib, which, where do we actually specify? There we go. So in sys1 parmlib, we're creating a DazD PM00 member, and this will be our DazD parameters. So again, to understand what all these are, you need to find the DazD manuals, the DazD System Programmer's Guide, whichever one has this particular file documented. You can see here we're creating the initiators. We have various defaults for all of our jobs, the number of punches and printers that we want our DazD to support. Here's our printer definitions, here's our punches, and now our readers. So what I'm going to change, these are the default conversion parameters for jobs that come into the system. And you can see that there's default parameters for time sharing user logons, for started tasks, and then for batch tasks. So when we submit jobs, they're going into the batch task. Now there's comments in this file. It's actually nice how they did this here that show each position of this conversion parameters line. What does that position mean? So for example, I can follow BLP authorization, disallow or allow. I can follow that up. That's this L parameter that goes up here. So in all three of these cases, it's 1, which means I want to allow. The one I'm interested in is this first one, which if we scroll down is the account programmer required. And this is saying, does the job card need to have the account number and the programmer name on it? If you have it set to, let's see, if you have it set to 3, both are required. If I don't have an account number and a programmer name on my job card, the system will reject the job. I can set it to require the programmer name, but not the account but not the programmer name, or none required, neither. Well, this is just my personal system. I'm not really accounting, who's doing what, who's using how much time. So for batch jobs, I don't really want to have to bother putting in just a bogus account number and programmer name to get the system to take the job. So I'm going to replace that 3 with a 0. So that will now be my default option for batch jobs, that I don't need a programmer name and account number on my job card. If we scroll down a little more, we see that we've defined our job classes, class A, B, and C. A and B look like they're using the default conversion parameters, but class S, did I see C earlier? I meant S. Class S has its own conversion parameters. And again, here you can see that first position is set to 3. So I'm going to change that to 0, and that way class S jobs won't need to have a programmer name or account number either. Okay. The DazD params are also where we see things like where the output classes are defined. So on this system, class X is what we're going to use for our held output class. So pretty much all the jobs that I run through the system once it's up and running, I'm going to say message class or MSG class equals X on my JCL job cards. And that will direct the output just into the held output queue, and we'll be able to look at that output online instead of all of it going to the printer or the virtual printer and just spewing out into that printer file that Hercules is managing on the hard drive. So once we have tools like Q or the output viewer in the review front end, it's nice just to review those things online in my interactive session instead of having them go out to a printer that I need to SSH into this machine and look at that Hercules printer output. Okay, again, lots of stuff you can change in here, but we just wanted to make that small modification that I like to make sure that I don't always have to put a programmer name and account number on my job cards. So let's save that, and we'll go over to our, let's go back to the instructions here. Okay, so this is telling us we can go ahead and run that JCL now. So let's go back to Hercules and run our SISGen4 JCL. Back to our operator console. Looks like that went pretty quickly. All available functions complete. Let's look at our completion code for SISGen4. Looks like we got 5 steps, all with a completion code of 0. So back to the instructions. That's exactly what we wanted to see. All right, completing the target system. So as the comment here says, technically the system generation is complete, but we do need to add several more files into our system for it to really be able to boot up on its own. And so SISGen3 is a job that's going to do quite a bit for us. If you've ever worked with the parmlib members in your turnkey system, you're familiar. This is where you really configure most of the options at the system level. So we can see this SISGen3 job is what's actually creating the initial copy of all of these various parmlib members for us. Setting up the various function keys we can hit from the MVS operators console, which will be convenient. Setting up our list of volume attributes. It looks like it's setting the time zone. So it looks like Jay Mosley is in Central Time, but I am in Pacific Time. So it looks like I'm going to want to edit this job stream to change that. Again, I could run this as is now, and then once I'm up and running in my system, go in and change these and then re-IPL for something to take effect, but may as well change them now. So again, if you look through this list, it's doing quite a bit for you. And this is really the core of a lot of the system configuration. So it's worth spending some time and maybe taking a quick peek at these, understand what each file is for, and you can make modifications as you wish. It's also creating some additional data sets for us to use with SMP in the future. It's creating our proclibs to use SMP. We'll see that in perhaps some later videos after the installation series where we're applying additional PTFs, maybe some other software that uses SMP. And again, it's just showing you a bunch of various stuff that it's doing here. So we saw that it sets up this time zone, parm_tz. So let's look at the SISGen3 job. SISGen3. And let's look for parm_tz. So there's a comment telling us it's going to create parm_tz. That's good. So here we are. So here we are adding the parm_tz member. And in this case, I want it to be west 8 hours. And this is the Pacific time zone. Again, I'm just going to make sure that all the alignment of the card sequence numbers stays in place. So in this case, Pacific is the same number of letters as Central, so everything stayed correctly in place. But again, you can see here, this looks like the VAT list. So these are the volume attributes telling the system how to use all of the DazD devices attached to the system and so on and so forth. It's just creating a lot of those parmlib and proclib members. So we'll save that with our time zone change. I think that's probably the only change that we need to make right now. And then we will go back to our instructions. And at this point, it's probably just going to tell us, yep, put this job stream into the card reader. So let's do that over in the Hercules window. And when we watch it run in our MVS operators console, let's load it into the system here. You can sing the Jeopardy theme or your favorite song. I'll just give it a minute here while we wait. Let's look at the instructions. We can... in fact, it looks like it's going to be prompting us. Yeah, I think this is probably a data set expiration issue, so we'll wait until we get a message that we need to reply to. Sure enough, there we go. So reply U to use or m.load, we want to use. So R10 U, again, we're always just paying attention to the number the system prompts us for, which could be different from the instructions or my run, just whatever your system is up to is what you want to use. All right. We haven't quite got the all available functions complete yet message, so we'll just wait. There we go. All available functions complete. Let's check our completion code there. Okay, looks like we got all zeros, which is always nice to see. And we expected all zeros. Okay, SISGen4. So this is more of the same. We're creating more of these initial files that are required for either some defaults or to get the system up and running. It looks like we're doing things that are going to get TSO, the time sharing option, able to start. As we look through the list here, this is setting up our 3270 terminals. So again, if you want to get a kind of a better idea of how the system works, it's worth looking through these various members in parmlib and proclib, because this is really the necessary configuration to get the system to the point where we'll be able to IPL it and bring up TSO so that users can log on. And this is everything that goes into being able to do that and have a basic functioning system. Now, the last thing this does is creates a customized network solicitor module, which is displayed to log on to TSO. I think this creates a little Hercules, ASCII logo screen so that when you connect a console as a regular user and you're going to log on to the system, it shows you that little logon screen. Personally, I'm not a huge fan of how this particular screen looks. So I'm going to modify this SISGen4 job stream to just not do this last step. And then we'll just be left with the default, very boring IBM network solicitor screen. There's instructions on the internet to change our screen if we want to, make our own little logo later. Obviously, we can just look in this job and modify the screen that it's creating. So I'll leave that as an exercise to the reader. But for now, just to show you how it's done, I'm going to remove this step from the SISGen4 job and hopefully not screw it up too badly. So SISGen4, we know it's the last step, so I'm going to go all the way to the bottom of the file. And let's just go up. Okay, so it looks like it's in several steps. This is step 3, assemble and link, edit the new netsol. So you can see here it has to be broken across the line, so it doesn't quite look like it will. But you can see, right, it's spelling the word Hercules out with the letters, so it'll draw big, ASCII art Hercules letters. It'll say welcome to MVS38J running under the Hercules emulator. Nothing wrong with that, right? This is just personal preference. What do you want your logon screen to look like? Okay, so we need to find the beginning of this. Update with changes to screen appearance. Restore the original source. And then this is probably now the previous job. Yeah, that's creating that's creating some aliases. Those will be important later. So it looks like I want to, starting around here, replace network solicitor screen. So I'm going to hit V for visual selection in Vim. And then I'm just going to scroll down through that job, or that step. So this step is what's actually updating that. We don't need any of that. This step assembles and links the new network solicitor. And what's this step doing? This is linking as well. So I think that's related to the network solicitor. Yeah, so let's just get rid of all of that. So I'm going to delete that. So I'm not sure what's assembling and linking here, but I think those are the previous steps. So I'll see if that works. All right. So save that. And if we, yeah, log tab and log mode were the previous steps. So I think we've removed the steps that are doing this. So let's make sure that when we do this, it looks like we should get all zeros, but with probably fewer steps because, again, we deleted the last step here. So let's run that JCL and see what happens. Over in the Hercules window, SISGen4, watch our console. Okay, that was pretty quick. All available functions complete. Let's look at our completion codes. Okay, perfect. So we got all zeros. That's good. Our last step was log mode 8, so we didn't have those extra couple steps that we deleted, which is what we'd expect. And we can move on. SISGen5. So this is kind of neat. This is a modification that will print the condition code. So, right, we've been having to go to our printer output for each of these steps to see what the completion code was, or the condition for each step was. So this is a system modification that will print on the MVS console what each step of every job, what its completion code was. So we can just very quickly see, if we're looking at the console, all the jobs that come in and what their completion codes are. It's pretty convenient. I really like it. So I'm just definitely going to run this guy as is. So back over in our Hercules window, run that. And give it a minute here. Okay, all available functions complete. We can check the condition codes from that job. All zeros, so that's what we like to see, just as we expect. SISGen6. So the community has built several nice modifications to the system. And so Jay Mosley here, for his instructions and in this job stream, has collected quite a few of them that really are probably the minimum set you want just to have a nice system. And so this collects all of these, and we will run that job to apply those to our system. Hercules window, load that JCL into the card reader, and we can watch this one run. And again, a lot of these, or in fact, all of these are now using SMP to stage that change and apply it to the system. And then, in this case, probably accept them back into the distribution libraries. So the job is purged. We'll just give it another minute for all available functions to complete. So it looks like probably to break it into multiple steps, this job actually creates additional jobs and then submits it to the internal reader. That way we don't have one big job that's too overwhelming for the system. So that's why you're seeing these various SISGen6 jobs start and then end. We'll just wait until it says all available functions are complete, and then we'll know that this job is really done. Again, if you're like, is my system doing anything? What's going on? You can always switch back over to the Hercules console. If you hit escape, you can see, oh yeah, sure enough, it's doing quite a bit of work. We're humming along, probably way faster than any real S370 ever was. I'll hit escape again, go back to our operator console. Oh, there we go. All available functions complete. So now let's look at our condition codes. So that was a big job. If we scroll up here, we can just head back up to the top. Lots of steps. That's why it broke itself into several jobs. Okay, so we have zeros. We have the occasional 4, which is probably expected. Yep, so 2 4s. Otherwise, it's all zeros. And looking back at our instructions, it looks like, yeah, so we're expecting a couple of 4s and everything else zeros. Okay. Last but not least, this is going to give us another version of the ICK DSF program. The ICK DSF program that comes with the system has no idea what these new 3375, 3380, and 3390 DazD volumes are, right? They didn't exist, and we just depend on that system modification in the previous step that taught our system what those new device types are. So if we want to initialize those devices and work with the device support facility tools, we're going to need a version that also understands what those new devices are. And this kind of explains the different versions. And there's, I think, an important note somewhere here that essentially, depending on whether you're working with the older device types or the newer device types, you either need to use this version 13 or the original older version 6. So again, for adding devices to the system, you want to be a little bit familiar with the fact that we have 2 different versions of ICK DSF, and you just need to know which one to use based on the device type you're using. So with all that said, there's just a job here to get that into our system. So we'll put that into Hercules. Look at the operator console. That is trying to load something new from tape. So let's look back at our instructions. That's going to pull off of the product tape again. So we'll mount that tape on tape device 170. So that is a Hercules command. And then back on our operator console, we'll reply to this message telling it we put that tape on 170. Okay, all available functions complete. Check the condition code of that. Anyone remember what that job was called? FDZ1D02. There we go. Okay, completion codes, all 0. Looks good. So that's it. Now for the last time, we are shutting down the starter system, and then we'll be able to boot into our real generated system. We started with empty DazDs, and we've now put everything we need to make a bootable system onto those disks. So we'll go through our regular clean shutdown procedure. We'll stop GES2, we'll ZEOD, and then we'll quiesce the system. So let's look back at our system here. First step, PGES2, and then ZEOD, and then quiesce. All right, back to Hercules. We can see the system is stopped. We can quit Hercules to power down the system. So that is it for this step. The system generation is complete. In the next video, we will boot up our newly generated system for the first time. And then from here, it's really just a matter of adding additional software that you want to the system and tweaking your configuration over time. So the sky's the limit, certainly, on what you can add and do to the system. We'll see some of that in the next video, like how you get an editor installed and some other utility programs installed that are useful. But that's it. We now have a system that we should be able to IPL, and we'll see if we can in the next video. Last note, this would be another good time to back up that DazD directory. You can see now we've, there we go. If I can type, you can see now we've filled up more volumes. Our system residence volume now has data in it. The additional system volume has data in it. So I'm going to go ahead and create an archive file, maybe post SISGen DazD.tar, and just include my DazD directory. This way, if I really start messing up the system trying to add additional software, I can again just always restore to this point from the installation instructions and have a nice known good working foundation to start over from without having to redo all the steps up to this point. So as always, thank you very much for watching. I hope you have found this interesting or informative or enjoyable or some combination of the above. We will be back in part 5, which will cover the final steps of Jay Mosley's instructions to add some software to this new system, as well as IPL it for the first time and see if it worked, which is very exciting. Well, thanks for watching, and I'll see you next time.